Hey everyone, welcome back. In this video, we're gonna talk about the engine sensors and actuators, location, operation, and wiring diagram. You already know that we have some videos on the channel for reading and analyzing the wiring diagrams for different cars. You can find the links for those videos in this video description. But in this video, we're gonna focus on the engine control system. We're going to talk about the sensors and actuators on the engine control systems. And at the same time, when we are looking at the wiring diagram, we're going to have a look at the real components location on the car. And we will compare the wiring diagram with the wiring harness on each component to see how we can really use the wiring diagram, not only in the theory. I'm pretty sure this video is going to be helpful for you when you are diagnosing any components on the engine, because diagnosing the engine electrical components can be a little confusing, especially when we are using the wiring diagram. So this video is going to be very helpful to learn how to use the wiring diagram to do the diagnostic on the car and how to identify each wires when we are doing the diagnostic. Before starting the video, if you guys haven't subscribed the channel yet, please don't forget to subscribe. And for finding our online courses, please check the video description. First of all, the wiring diagram that I'm using today is for a Kia Rio 2012 with 1.6 GDI engine. But the procedure for reading the wiring diagram is almost the same in other cars as well. So it means what you see in this video is going to be very helpful for diagnosing the other cars as well, because the wiring diagrams are pretty much the same even if the design is a little different. As I said, we're going to focus on the engine control system wiring diagram, and we're going to go step by step, one by one. What you see right now on the screen at the middle, before starting to talk about these components, this part at the center is PCM, which is powertrain control module, or something that we call it engine control module. This part at the top is part of the engine fuse box that I will explain later on. Let's go for identifying the components one by one. The first part that you see here is Purge control solenoid valve. Purge control solenoid valve, or PCSV, is what we call it as EVAP solenoid valve, or sometimes canister control valve as well, which is responsible to release the fuel vapor from the canister into the intake manifold, because inside the fuel tank we have some fuel vapor. That fuel vapor gets absorbed by the charcoal canister and later on can be released into the intake manifold when ECM opens this solenoid valve. Let's have a look at the location. This is the Purge control solenoid valve, which is normally located on the intake manifold. As you see, we have two hoses on the solenoid valve. This hose is coming from the canister, and the other hose right here is connected to the intake manifold. That hose which is connected to the intake manifold is exposed to the engine negative pressure, or engine vacuum, when engine is running. So it means when ECM activates the solenoid valve, engine vacuum from here can suck up the fuel vapor into the intake manifold and finally into the engine to burn it inside the engine. So you see on this solenoid valve we have two wires. Same story on the solenoid valve itself. You see this white wire right here is the power supply, which comes from the fuse box. It means when ignition switch is on or engine is running, you should expect the power supply over here. This is supposed to be battery voltage or charging voltage when engine is running. And this yellow wire that you see here and on the solenoid connector, this is the control line. As you see, PCSV control, which is connected to the PCM. So anytime that ECM wants to activate this valve, it's going to provide the ground from here to turn the solenoid on. Next part is variable intake solenoid valve. So variable intake manifold system consists of a solenoid valve that you see right here and a diaphragm which is mounted right down there. So there are two hoses on this solenoid valve. One hose is connected to the intake manifold carrying engine negative pressure, and the other hose is connected to the diaphragm. And diaphragm is connected to a group of valves to change the air path inside the intake manifold. So variable intake solenoid valve is responsible to change the air path inside the intake manifold to provide a better amount of air to the engine. And those valves are controlled by this diaphragm. On the valve, as you see, we have two wires. That gray wire is the power supply for this solenoid valve that you should expect battery voltage when ignition switch is on. And this black wire is the control line. Oil control valve, or OCV, it's sometimes called VVT solenoid valve. You may have one or up to 4 oil control valves. For example, on this car, we have 2 oil control valves that you will see very shortly. Oil control valve number 1 refers to the intake side. As you see the location, here is the intake manifold, and oil control valve is located right here on the intake manifold side, which is responsible to control the oil to intake VVT. If this control valve is faulty, you may have PW011 or PW016 fault codes, which are really common. On the solenoid valve, as you see, we have 2 wires. That gray wire on the right, which is right here at the top, is the power supply, like the other solenoid valves that I just explained. Pink wire down here is the control line for intake OCV. You see the intake here? This is actually referring to the intake VVT. And exhaust control valve, which marked here as number 2, this is the oil control valve, which is mounted right here at the top. This is for controlling the exhaust VVT. Very same thing for controlling the exhaust camshaft timing when engine is running. On engines, normally we have 2 oxygen sensors, one before cat, the other one after the cat. Sometimes we call it upstream or downstream. What you see right here as down is referring to downstream oxygen sensor, which only has 4 wires in this case, 2 wires for the heater of oxygen sensor, and the other 2 wires are actually the ground and signal. So this oxygen sensor is located after the cat for monitoring the cat performance. This is the connector on this car. As you see, we have these 2 gray wires right here as pin number 3 and 4 for the heater. It means if you have a fault code for oxygen sensor heater, you can check the resistance of the heater if you measure the resistance between pin number 3 and 4. And pin number 1 is the output signal of this sensor. Downstream oxygen sensor can turn the check engine light on if it detects the low efficiency of the catalytic converter or if the sensor itself is faulty. In both cases, you may have higher emission and higher fuel consumption. Of course, we have another oxygen sensor before the catalytic converter that we call it sensor 1 or upstream sensor. This sensor is really important for measuring the air-fuel ratio. This sensor is going to monitor the amount of oxygen in the exhaust gases, and ECM will calculate the air-fuel ratio by the signal which is provided by this sensor. This sensor can come in 2 different designs, wide band or narrow band. If you have a narrow band oxygen sensor, you have only 4 wires on the sensor. What you see right now on the screen is for a wide band oxygen sensor, which provides 6 wires as you see. 2 wires out of these 6 wires are for the heater, as you see right here. Pin number 2 and 5, these 2 gray wires are for the heater. Same story like the downstream oxygen sensor. So those 2 wires at the middle, which are gray, they are for the heater. And the other 4 wires are actually for the sensing element. On this engine and this wiring diagram, we have GDI fuel system, which is gasoline direct fuel injection system. It means in addition to the low pressure fuel pump, which is inside the fuel tank, we have a high pressure fuel pump, which is mounted at the top of the engine over the cylinder head. So this is the high pressure fuel pump, and what you see on the left side is the fuel pressure control valve or fuel pressure regulator. This high pressure pump is going to increase the fuel pressure up to 140 bar. At idle, the fuel pressure is going to be around 40 bar. When you are accelerating at acceleration or high load, this fuel pressure can reach up to 140 bar. Because the fuel pressure provided by this high pressure pump is not going to be the same all the time. So there should be some sort of control on the fuel pressure output. That's why we have this fuel pressure control valve mounted on the high pressure pump to regulate the output pressure. So when engine is running, ECM keeps looking at the fuel rail pressure sensor that we will see shortly. And based on the information provided from the fuel pressure sensor and of course the engine current running condition, it's going to regulate the output pressure of the pump by using this fuel pressure regulator valve. If there is anything wrong with this valve, you will have some fault codes like fuel pressure too high or too low. And of course, it's going to affect the engine running condition and engine power as well. So it means if fuel is not regulated properly, if fuel pump is providing higher pressure, injectors will inject more fuel, which is going to cause rough engine and bad fuel consumption. If this fuel pressure regulator is regulating the fuel too much and fuel pressure is too low, injectors won't be able to provide enough fuel to the engines, and of course you will have poor acceleration as well. On this control valve, as you see, we have two wires. The white one, which is connected on the negative side of the valve, and brown one, which is connected on the positive side of the valve. ECM controls the positive and negative accordingly to reach to the proper percentage of the valve operation based on the engine driving condition. This valve is a solenoid valve, so not only we can check the wiring, we can proceed for checking the internal resistance of the valve as well. You see 4 injectors right now on this wiring diagram, and you notice that the injectors are connected directly to the engine control module. On many cases, if your car has MFI fuel system, out of 2 wires on the injectors, one is coming from the fuse box, bringing the power from the fuse box, which is going to be the battery voltage, and the other one is the control line connected to the ECM to control the injector operation. But because this car has GDI fuel system and GDI injectors, both wires on the injectors are connected directly to the PCM. This is very important when you are diagnosing the injectors, to have a look at the wiring to make sure what sort of wiring you should expect. This is a photo of the fuel rail exactly for this car. You see the injectors, and as you can see on the injectors, we have 2 wires, the pink one and the blue one. The pink one on the positive side of the wiring and blue one on the negative side of the wiring. If anything goes wrong with the injectors, you will have misfire, you will have bad fuel consumption, or engine is gonna run rough. And on the left side, you see the grounds for PCM. So in case of having any issues with this ground, you may have no starting, you may have no communication between the PCM and your scan tool. So it means if engine is not starting and you are trying to hook up the scan tool to read the fault code and the scan tool is not communicating as well, one cause could be the power or ground on the PCM. So these 3 pins, pin number 1, 2, and 4, they are actually responsible to provide the ground on PCM. I'm going to show you later on how to find these pins on the PCM, how to find the relevant connector, how to find the pins as well to perform the proper inspection on the PCM. These 2 fuses at the top, which are providing the power supply to some components, for example, sensor 1 is going to provide the power supply to PCSV and variable intake manifold system. And sensor 2 is providing the power supply to the oil control valves and oxygen sensors. In case of having any issue with these fuses, if sensor 2 fuse is broken, you will have malfunction on all these 4 components. But how can we find them? They are located inside the PCB fuse and relay box, which in this car is a part of the engine fuse box. So right now you see the engine fuse box cap providing the information from all the fuses inside the engine fuse box. So right here we don't have anything exactly with this name. So this is the diagram for this car. This is the fuse box cap for this car. But as you see, there is nothing as sensor 1 and sensor 2. Sometimes some companies are going to make it a little confusing when it comes to some cases like this. So that's why we need to have a look at the wiring diagram. In the wiring diagram, we will find this part as the PCB fuse and relay box. So this part that you see is exactly this part on the fuse box. So if you look at here, F29 and F30, they are sensor 1 and sensor 2, which are just right here. So these 2 fuses are actually these 2 fuses. 21 is the one down here, and F30 is the one up here at the middle. And you see these relays on here on the wind diagram. There's nothing shown in here on the fuse box cap because these relays are installed internally inside the PCB fuse and relay box because this company wanted to make the fuse box more compact. That's why instead of just using a normal relays that we see in the market, they install the relays internally. We have some videos on the channel about this kind of fuse box. We are on the second page of wiring diagram on this car, and of course some more sensors and actuators. Let's start by the camshaft position sensor. Camshaft position sensor is normally responsible to detect the position of the camshaft or helping the ECM to detect the engine timing. So this sensor that we are looking at right now is the intake camshaft position sensor, which is mounted right here on the engine. So as you see at the rear side of the engine, on the intake side, we have the intake camshaft position sensor. We may have only one or up to 4 camshaft position sensors on one engine. This engine has 4 cylinders and 1 bank, so we have 2 camshaft position sensors, one for the intake, one for the exhaust that we will see shortly. Any problem on the camshaft position sensor is going to cause no starting, and some fault codes like P0340 is actually one of the most common fault codes for the camshaft position sensor. This sensor that you see right now is a Hall effect type. That's why you see 3 wires on the sensor. All these 3 wires are connected to the PCM. So you see the pin number 1, the gray one, is the power supply, which should provide a 5-volt supply to the sensor. Pin number 2, the green one, is a sensor signal, which is located at the middle on the sensor itself. And pin number 3 is the ground of the sensor, which is provided by the PCM. So we can check the sensor wiring with the multimeter, but the best way for checking the sensor operation is the oscilloscope on the signal wire. We have another video for checking this one as well. Camshaft position sensor on the exhaust side is going to work exactly like the intake side and is mounted right here on the cylinder head. This sensor is going to detect the position of the exhaust camshaft, and same story, it has 3 wires like the previous one. Pin number 1 is the power supply, pin number 2 is the signal, and number 3, which is a white wire, is the sensor ground. But one of the most important sensors for the engine operation is the crankshaft position sensor. This sensor could be located at the front side of the engine or at the rear side of the engine. So anytime that you have any issue with this sensor, the first thing is to locate the sensor to see if it is at the front or at the rear side. This sensor is going to detect the position of the crankshaft, and because we have only one crankshaft, we have only one crankshaft position sensor as well. This sensor is really important for detecting the position of the crankshaft and of course the position of the pistons, because PCM uses the information from this sensor to locate each single piston. And of course this sensor is used for some other purposes as well, for reading the engine RPM or for detecting misfire. Some fault codes like P0335 is actually one of the most common fault codes for the crankshaft position sensor. And generally when you have any issue with the crank sensor, you may have no starting. And sometimes engine will start but with a long delay. For example, on this engine, sensor is located at the rear side, but they made the connector available for everyone to do the diagnostic. Instead of just going under the car, you can reach to the connector like that. The crankshaft position sensor can come in 2 different designs as well, inductive type or Hall effect type. If it is Hall effect type, it's going to be exactly like the camshaft position sensors with 3 pins. But if it is inductive type, you have 2 wires on the sensor. As you see, in this case, we have 2 wires, a white wire and a brown wire. In this kind of sensors, because it's inductive, we can check the internal resistance of the sensor and we can check it with oscilloscope. Throttle body is very important for the engine proper operation. So anytime that you accelerate, when you press the gas pedal, you are actually sending a request to the PCM, and PCM is going to open the throttle body to provide more air for the engine. Opening the throttle body is going to happen through an actuator, but for reading the current position of the throttle body, we need 1 or more sensors. In this case, we have 2 sensors. These sensors are potentiometers providing variable resistor based on the throttle position angle. So these sensors are called TPS1 for throttle position sensor 1 and TPS2. Anytime that throttle body opens or closes, The resistance value on TPS1 and TPS2 will change, and of course it's going to change the output voltage of the sensors as well. By reading the output voltage of the sensors, PCM will understand the current position of the throttle body and is going to hold the throttle body plate at the required angle. If there is anything wrong with the throttle body, you may have check engine light on, limited engine RPM, or weak acceleration. Here is the wiring of the throttle body exactly for this car. So you see pin number 1 and 2, they are for the throttle body actuator, which are these two wires, white and blue wire. Down here you see this white wire, pin number 1, and pin number 2, this blue wire. These two are for the throttle body actuator, and the other 4 wires are for the throttle position sensors. So pin number 3 right here is the ground for TPS1 and TPS2. Pin number 4, this pink wire, is the output signal for TPS2. Pin number 5, this orange wire, is the power supply for TPS1 and TPS2. And pin number 6 is the output signal of TPS1. So it means by knowing this, you can check the power supply on the sensor on pin number 5, which is this orange wire, that you should expect a 5-volt supply. And you can check the output voltage of each sensor by monitoring the voltage on pin number 4 and pin number 6. Engine coolant temperature sensor is the next sensor on this engine control system. PCM monitors the engine temperature by reading the signal from this sensor. This sensor is actually a NTC sensor, negative temperature coefficient. It means the internal resistance of this sensor is inversely proportionate to the temperature. When temperature goes higher, the internal resistance of this sensor is gonna drop. So based on this fact, you can check the sensor internal resistance on different range of temperature. So this sensor is located very close to the thermostat housing. You see the sensor down there, and here's the sensor connector, which is already disconnected. So you see 2 wires on the sensor, the pink one and green one. Green is the sensor ground and pink one is the sensor output signal. APT, or AC Pressure Transducer, is a sensor for measuring the pressure on the AC system. PCM uses the information from this sensor to control the operation of the AC compressor. So you see the sensor location right here, and as usual, this sensor is equipped with 3 wires as well, ground and power supply and signal. Rail pressure sensor is mounted on the fuel rail. And because this engine has GDI fuel system, as I explained earlier, there should be a sensor on the fuel rail to read the current pressure. So this sensor is mounted on the fuel rail. As you see, this is the fuel rail, and sensor is located right here. So when engine is running, PCM keeps looking at the information provided from this sensor to regulate the high pressure pump operation. If this sensor goes bad, PCM cannot regulate the fuel pressure, and it's going to end up to having high pressure or low pressure inside the fuel rail, which is going to affect the engine running condition and fuel consumption. On this engine as well, as you see on the photo, we have 3 wires. Pin number 1, which is right here, this red wire, is the power supply on this sensor, which is provided from PCM, which we are expecting a 5-volt supply. Pin number 2 at the middle, this pink wire, is the sensor output signal, and pin number 3 is the sensor ground, and this one is provided by ECM as well. MAP sensor, or manifold absolute pressure sensor, is mounted on the intake manifold to detect and read the pressure of the intake manifold. And of course, we know that inside the intake manifold, we have the engine negative pressure, but this sensor is mounted very close to the throttle body as well. So the throttle body opening angle is going to affect the signal generated by this sensor. ECM uses the information from this sensor to calculate the air-fuel ratio, because the air pressure is going to affect the air-fuel ratio. This sensor can come in 2 different designs. Sometimes you have the MAP sensor with 3 pins, sometimes with 4 pins. If you have the MAP sensor only with 3 pins, it's only the MAP sensor, nothing else. In case of having 4 wires, intake air temperature sensor is integrated with this sensor as well. That's why right here you see the IAT signal, IAT for intake air temperature sensor. So right here, this element is for the MAP sensor and this element is for IAT. Both these sensors are really important for correcting the air-fuel ratio. So having any issue on these sensors means we will have rough engine and bad fuel consumption. Let's have a look at the real wiring on the map sensor on this car. So you see the pin number 1, a pink wire, which is the sensor output signal, map sensor output signal, which is right there. Pin number 2, this blue wire, is the map sensor supply, which is a 5-volt supply provided by PCM. Pin number 3, this yellow wire, is the IAT sensor output signal. And pin number 4, this orange wire, is the ground for both IAT and map sensor. Knock sensor is normally mounted on the engine block. We may have one or more knock sensors. Majority of the times we have 2 knock sensors. And this knock sensor, which is bolted on the engine block, is going to measure the knock generation by the engine. Of course, when engine is running, anytime that the spark is happening, there is a small knock generated by the engine. But if there is a big knock, this sensor is going to measure that as well, and is going to inform the PCM. And PCM will control the knock generally by retarding the ignition timing. If this sensor goes bad, PCM doesn't have any reference to find the knock, and it cannot control it as well, so engine is going to generate knock. And because this sensor is mounted on the engine block, you can find it on the engine block as well, or on some engines they have made the connector available right there for better diagnostic. We have 2 wires on the knock sensor, the black one and the red one. The black is the ground and the red one is the signal. Inside the knock sensor we have a piezoelectric element, which is going to generate electricity anytime that the knock is happening. On the next page, we have the ignition coils. Of course, you may have different type of ignition coils. You may have wasted spark. You may have coil-on plugs with 2 wires, 3 wires, or 4 wires. We have different videos for all of them in our channels, so you can find the videos on the video description as well. In this one, we have coil-on plug with 2 wires. So you see the ignition coils are numbered in here. Ignition coil number 1, number 2, number 3, and number 4. Inside each ignition coil, we have a primary circuit. So this side is showing the primary circuit, and this is the secondary circuit. So ignition coil is responsible to provide high voltage that we need for the spark. When engine is running, charging system is providing a voltage a little higher than 14 volt, which is not enough for the quality spark that we need for the engine. So the ignition coil is going to increase the voltage to thousands of volts that we need for a quality spark. And this is going to happen by inducing the voltage from the primary to the secondary coil. So it means on this kind of ignition coils, on the ignition coils with 2 wires, we can check the resistance of the primary circuit and resistance of the secondary circuit as well. On the wiring side, as you see, we have power supply provided to all ignition coils from 1 fuse inside the IP junction box, which in this case is the interior fuse box. So this fuse is going to provide the power supply to all ignition coils. So if this fuse is broken, you won't be able to start the engine. So this is actually one thing that you might need to check when you can crank the engine but no starting. All the ignition coils are controlled individually by the PCM. So these lines are the control line. In case of having misfire, if one ignition coil is not working, checking the control line can be very important. Let's have a look at the ignition coils. So you see the photo of each ignition coil in this case. For example, for ignition coil number 3, you see 2 wires over here. The pink one is the power supply and the red one is the control line. For ignition coil number 1, we have the green one as a control line and still pink one for the power supply. Again, on here, pink wire is the supply and the black one, this black wire is the control line. And ignition coil number 2, we have a white wire for the control line and pink for the power supply. So this is how you can find the wires to inspect the power supply. And if you are trying to use the oscilloscope to read the waveform of the ignition coil, you need to insert the back probe on the control line to read the waveform of the primary circuit. Just in case if you cannot start the engine because of this fuse, you can locate it right here. This is the interior fuse box cap. So 15 amp ignition coil fuse is mounted right here that you can find it easily on the interior fuse box, which is normally under the dash on the driver's side. The other fuse that we have right here, this 15 amp, this is actually for PCM input voltage when ignition switch is on or when you are starting the engine. So this is really important for starting the engine. If this fuse is broken, you may have no starting or you may have no communication between the scanner and PCM. Another very important sensor on engine control system is accelerator pedal position sensor. If you have electronic throttle control, there is no mechanical connection between the accelerator pedal, and the throttle body. So it means anytime that you press the gas pedal, there should be one or more signals sent to the PCM to inform the ECM about the driver intention, and PCM can control the throttle body by opening the throttle body plate using the throttle body actuator. So for sending the signal from the accelerator pedal, we have one or more sensors inside the throttle body. In this case, we have two. These sensors are potentiometers and are going to work exactly same as the throttle position sensors. It means when you press the gas pedal, you have changing resistance over here, which is going to affect the sensor output voltage. In this case that we have two, we have APS1 as accelerator pedal position sensor 1 and APS2. For each one of them, we have a supply, which is a 5 volt. We have a ground, and we have a signal which is going to change based on how far you are pressing the gas pedal. We have a full video for checking the accelerator pedal position sensors on video description. Here's the pedal itself. You see the sensor is mounted right at the top, and here's the sensor connector. We have 6 wires on this sensor, 3 wires for sensor 1 and 3 wires for sensor 2. As you see, pin number 1, that yellow wire is the signal for APS2. Pin number 2, this blue wire is the supply for APS2. Pin number 3 right here is the supply for APS1. Pin number 4, that white wire, is the signal from APS1. Pin number 5 and 6, they are ground for APS1 and APS2. Having the malfunction on this sensor is going to cause limited engine RPM, weak acceleration, and sometimes no starting. So we already covered all the sensors and actuators on this engine, following the wiring diagram and locating the components and the wiring diagram on the car as well. But there is one aspect of it which is really important. On the sensors or actuators that we have just a few pin numbers, it's really easy to locate them because normally they come in different colors. It's really easy to find them. But when it comes to something this complicated, as you see, this is the ECM connector. When it comes to the ECM connector or some connectors like this, very complicated, it's going to be very confusing to find the pin numbers. And why do we need to find the pin numbers? Have a look at here on EVAP control valve. As I said, we have power supply on the EVAP control valve. We have the control valve itself here. Just imagine that you have an issue that the valve itself and the power supply, they are all okay. You think that there might be some issue on the control line, but you cannot come to a conclusion that this wire is bad before making any measurement. You need to find the wire and inspect it. For finding the wire, you need to find one end on the valve itself, which is of course really easy because on the valve we have only 2 wires, but the other end of the valve is inside the PCM connector, and it's going to be a little hard and confusing to find it right here. So right now I'm going to tell you how to find it. On this wiring diagram, this yellow wire is connected to the PCM to a pin number which is 7. But what connector? Because on this car, on the PCM, we have 2 connectors. The connector code in this case is EGGAA, which is right here. I found this photo from the wiring diagram. And the pin number that we are after is pin number 7. So it means you just need to look up for this connector code in the wiring diagram, because wiring diagrams normally include the connected details as well. And after finding this one, you can identify the pin numbers. So this is exactly this connector. So you see some bigger pins over here, some bigger pins over there. So this side we have some bigger pins, just a little bigger than the other ones, not too big, just a little bigger pins. And you can identify the pins by looking at this. So you see some numbers on the connector as well. Sometimes they provide some numbers to make our life easier. So if we see the pin number 85 is just written upside down. So this pin number 85, which is written here, is just right here. This is pin number 85. And on the other end, you see 105, which is 105 right here. This side down here, we have pin number 1, which is pin number 1 right here. So what we need to do, we need to just find pin number 7. Pin number 7 is right here. So you need to keep counting from here to reach to pin number 7, which is here on the connector detail and here on the connector itself. If I count from here, it's going to be like this: 1, 2, 3, 4, 5, 6, and 7. So this is the other end of this wire from the PCSV to find it out. If you have a very thin test probe, you might be able to check it from here as well. If your test probe is thick, you shouldn't insert it from this side of the connector. You can just turn the connector around and back probe from the back. And of course, finding this wire from the back is not that much of a big deal right now because we found the pin. We already know the color as well, so it's going to be really easy to find it out. So this was actually a review from all the sensors and actuators on this engine by considering the wiring diagram, their location, and their symptoms. As I said, we have many online courses, including one full online course for all engine sensors, which is a 4 hours online course for all engine sensors. In that course, I explain how to check each single sensor with multimeter, with the scan tool, and we use the oscilloscope and sensor simulator as well. Thank you very much for watching. Please don't forget to subscribe to the channel and visit the channel for more videos.